They make a lot more sense now. Okay, let me talk a little bit about these trig functions. Then we're going to start integrating. I don't think I can do justice to it in 10 minutes. 30 questions? No? And do just do it in 10 minutes, but let me start. So you're going to need some tricks here. I don't think you'll have any trouble with some of them. What you're going to end up doing is taking a bunch of complicated trig integrals and busting them up using a whole bunch of different tools into simpler trig integrals. But the simplest they're ever going to get is going to be things like this. Now, how would you anti-differentiate that? What would you do to find the antiderivative of that? A u sub, what would you let u be? Sine of x. Perfect choice. This is equal to the integral of sine of x all squared times cosine of x dx. And since the derivative of sine is cosine, a natural choice is u is sine x. I won't do the work. I'll just write the answer. Why? Because if I take the derivative of this would be 3 sine of x squared times the derivative of sine, which is cosine. With 3 and the third would cancel, and that's what I ended up with. Okay, so that's a pretty simple problem. Now, suppose the cosine weren't there. Well, now you could try u sub with u equals sine of x dx, or u equals sine, but then du is cosine of x dx, and I don't see a cosine anywhere in there to substitute that. So I'm stuck.
U is sine x or sine squared x?
Well, we could try, I tried sine x, but I got stuck because I ended up with a cosine, and I don't see a cosine, you know, there's no way to, I mean, if I solve for dx, I get du over cosine. So I put du over cosine, but how am I going to get rid of that cosine? Okay? So you suggested maybe I should try u equals sine squared of x. Then du would be 2 sine of x cosine of x dx. Okay, now I've still got cosine hanging around that I don't like. So this is when that trig course you took or didn't take either pays you back or kicks you in the butt. Sine squared of x over 2 is equal to 1 minus cosine of x all over 2 is a trig identity. It's called a half angle identity. Somewhere around page 187, Appendix T has all the trig identities that you might possibly want to know that you may have forgotten. So you can, of course, they're anywhere to be found on the web, but sometimes they're written differently. For example, this one, if this is true for every x, then it would be true for t. It would be true for if t is a number and twice t is x, in other words, half the value of x. If it's true for x, it would be true for 2t. So I could put that in there and say sine squared of 2t over 2 equals 1 minus cosine of 2t over 2. And that's the way you often see it written, because now the t's cancel, and so you get sine squared of t equals 1 minus cosine of 2t over 2. All right, so what's my point? My point is, this is the half angle identity. That's always called the half angle identity because it's how to bust up half angles. But I didn't like the way it was written, so I rewrote it. Now I'm going to use it in that integral right there. I'm going to say that whole thing is equal to 1 minus cosine of 2t all over 2 dt. And my claim is that's two really easy integrals. How do I bust it up?
One minus cosine 2t times 1 half.
Right, multiply it to make it 1 minus cosine t all times 1/2, so I can throw that half out front and just have this. Right? Dividing by 2, same as multiplying by half. Those are two easy integrals, so that's 1/2 times t. Now let's see, what do I need? I need sine 2t to get this. Sine 2t would be cosine 2t times 2, so I better throw another half in there, and I better leave the negative in there. And I'll throw the k on the outside. Right, here to t is 1. Here to this should be cosine 2t times 2, which cancels with that, and that keeps the negative. So the whole thing is 1/2 t minus 1/4 sine of 2t plus your favorite constant. Maybe it's gamma.
Can I ask a question about the identity?
Mm-hmm.
I mean, if you didn't change it to with the 2t, where does the 2 come from? Because I know sine squared x plus cosine squared x is 1. So I see how that's 1 minus cosine squared x.
Well, so if sine squared x plus cosine squared x is 1.
Oh, because it's x over 2, I'm sorry. It's not just x, it's x over 2 that
right.
Identity is.
Yeah,
okay.
so if you put x over, so sine squared of x over 2 plus cosine squared of x over 2 has to be 1 also. Because this is true for any value that you put in here.
Okay. So the identity is over 2.
Okay, so now let me point out, suppose I wanted to integrate something worse, like sine cubed of x dx. Well, again, I know the derivative of sine is cosine, so there's no point trying to use sub because I don't have a cosine up here, right? So what am I going to do? Well, I'm going to break it up like this. And now, it turns out there are two really neat ways to do it, which if I had more than 55 seconds, I'd show you both of them. You could do integration by parts with u equals sine squared of x and dv equals sine of x equals dot 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 dot. Or you could do this. This is sine of x times, remember that sine squared plus cosine squared is 1, so sine squared is 1 minus cosine squared. That makes it two easy integrals. Sine of x minus, I'll break it into two integrals, just pull it outside here, cosine squared of x times sine x dx, which I can now do a u sub with u equals cosine of x.
Cool.
Now, I'm out of time, so I'll just write equals star, and they agree. So you can work it both ways, see if you can get the same answer. But that gives you a kickstart on how to do those upcoming trig integrals.